All right, here we are, Unit 1 integers, and we are now on subtracting integers 1-2. So go ahead and write your date in here, and then we're going to record in our learning goal, which is learning goals number 5 and number 6. So let's take a look at what those are. Down here, number 5, I will be able to subtract integers. And then number 6, I'll be able to write equivalent numeric expressions. So today that means that we're going to be able to write expressions as an addition statement as well as a subtraction expression. And those two will be equivalent to each other. Looking down at the actual lesson itself, go ahead and get here in your notes and follow along and record down everything exactly as we share it today. So key concepts for subtracting integers. First of all, the thing you have to understand is really you never are going to have to subtract integers. If you understand this concept that subtraction can always be changed to an addition equation, then you just remember your adding integers rules and you're all set to go. But it's good to understand both concepts as well. So we understand that subtraction, all the way from when you were in elementary school, is the concept of taking away. So you have 5 apples, take away 3, now I have less type of thing. We're going to be focusing on today that we can write 2 equivalent expressions as a sum or as a difference. And they'll be equal to each other. That's what equivalent means. So let's take a look at example number 1. These are our number line expressions. We've already done the sum in the last lesson, so nice little review here. We always start at 0 to identify our first number, and we see that it is going to 6, so our first number is 6, and we're writing the expression as a sum, so an addition expression, and so now we are adding the negative amount because we see it's going to the left. So let's identify what that is. I can bunny hop my way over there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is a negative 11 that we're adding on to there. And we finish at a negative 5. So we know that's the value of this expression. Now, at the same time, we can write it as a difference, just as a normal subtraction problem like you're more familiar with in younger grades. And so now we can look at the same situation, and we're starting off with 6 again, and we just identify, okay, well, how much are we taking away? Well, I already know that I'm taking away 11, and so that's just 6 minus 11. And so that's what I want you to be able to see here when you look at this is, if you look at this here, we have positive 6, and then we're also adding a negative 11, and you end up with this result. You could look at it the same way. I have a positive 6, and I have a negative 11, and the difference of those ends up being a negative 5. Okay. All right, so let's look at the next one next to it here. So let's take care of this, and let's show it as a difference first this time. So we're starting at 0. Our first digit goes to negative 4. So our first digit is a negative 4, and we're still moving to the left. So how much are we continuing to take away and subtract? So I can see 1, 2, 3, 4, 5, 6. So I'm taking away 6 more. Or even look at this way. I have a negative 4 and a negative 6. That helps us sort of see the additive expression as well. And we end up with a value of negative 10. Okay. If we turn that into a sum, think about what I just said there. I have a negative 4. Okay. And I also have, we can add the negative 6 on there. So it's sort of like just putting the addition symbol in there to show that you have a negative 4 and you also have a negative 6. Okay. All right. Moving down to some other subtraction expressions. Let's go ahead and think about the number line and the concept of taking away. So you don't have to draw the number line every time, but I do want you to try to visualize that a little bit. Okay, so I can see that I'm starting at the positive 5. Okay, so if I'm visualizing the number line, here's my 0. Okay, I know I'm starting at a positive 5, and then I'm taking away, okay, 10. And so I know from here that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then I have to think about where I am. So if I reduced 5, that's at 0, and then another 5 puts me at negative 5 over here. So I know that this equals negative 5. Okay. Think about this, though. That's also the same as 5 plus a negative 10. And we do know our rule from before where we said same signs add and keep, different signs subtract. So you can see 10 minus 5 is 5. Keep the sign of the bigger digit, then you'll be exact. And so this matches and makes sense. Okay, let's go ahead and do the next one. Okay, so again, I visualize my number line. I'm already starting off at a negative 3. Okay, and so here's my first number is negative 3. I also have a negative 5. So if I also have a negative 5, I'm taking away even more, okay? And I'm reducing this by another 5. 1, 2, 3, 4, 5. Where do I end up? So what's an additional 5 taken away from where we were at 3? So all I'm thinking is 3, 4, 5, 6, 7, 8. And so I'm at negative 8. Okay, let's sort of think about our addition as well. So we have a negative 3, and I also have the negative 5. Okay, so I can think about it like that as well. Same signs add and keep. So 5 plus 3 equals 8. Keep the signs. Okay, so that matches. All right, now this one's sort of ugly looking with the negative in parentheses, negative. And remember, anytime we see a subtraction symbol right outside of a parentheses or a subtraction symbol right outside an absolute value, do you remember what we say when we see that? If you said opposite, then you are right. So basically what I see here is I have a negative 3 and I have an opposite of negative 7. So if you sort of think in your head, well, what's an opposite of a negative 7? Anything else gets sort of like confusing with this, okay? But I just know the opposite of a negative 7 is a positive 7, okay? And so I actually have this, okay? Isn't that the same thing? So this is what we end up with, is a negative 3 plus 7, okay? And so I know my addition of integers song, same signs add and keep, different signs subtract. So 7 minus 3, 6, 5, 4. Keep the sign of the bigger digit. The bigger digit is the 7, which is positive. Then you'll be exact. And so I know I'm all set. And this is reasonable, makes sense because the 7, the positive 7, there's more of that than the negatives. Okay? All right, let's go ahead and look at this example. This is another trick plenty of people use called KFC, and it's called keep, flip, change. And if you have trouble understanding the concept of this, it can just be another trick to help you solve subtraction integer expressions. So here's the trick with this. You keep the first number, okay, exactly how it was. And so as I'm talking about it, let me just sort of talk through this with you, okay? So we'll look at this one right here. So I'm going to keep the first number as a negative 1, and then we're going to flip the subtraction sign to addition. And so instead of the subtraction, I'm going to make it addition. And then it says change the number, or sorry, change the last number to its opposite. Okay, and so you really have to sort of separate those out, though. So let me sort of show you what I mean. So here's the first number, okay? Here's the sign, And then there's this. If you look at the number very, very separate from that subtraction symbol. So we're saying keep the first number, flip the subtraction to addition, and then change the last number to its opposite. So if I'm just isolating and looking at that last number, 26, I know that the opposite of 26 is negative 26. Okay, so it's just a trick to change it to an addition expression. But if you just look at something like this and you see that I have a negative 1 and I have a negative 26, you can just sort of say, oh, I have a negative 1 and I have a negative 26. And that's the same thing also. So it's up to you how you want to think about it. Okay, let's go ahead and we'll think about it both ways as we continue the rest of these. Okay, so keep, flip, change, KFC. So I'm going to keep the negative 24. I'm going to flip the negative to a positive, and then I'm going to change the last number to its opposite, which is a negative 28. Or again, I can just look at this as negative 24 and a negative 28, and then I'm done. Okay. If you look at them as two separate numbers. All right, so let's look at the next one. We have a negative 19. And what is this? Remember when we have this weird situation where we have a subtraction outside of the parentheses? What does that actually mean when I see this? If you said opposite, you are correct. So this number here is the opposite of negative 11. So what is the opposite of negative 11? The opposite of negative 11 is positive 11. And then you can see I already have my addition expression. But let's go ahead and look at that with keep, flip, change, our KFC trick as well. So KFC says keep the first number, flip the subtraction to addition, and change the last number to its opposite. And that's technically positive 11. So you can see it creates the same thing. The other method just simplifies it a little bit more. But whatever you're comfortable with. All right, last one. Let's go ahead and look at this. Again, I have the symbol outside of the parentheses, so we know that symbol means opposite. And so what is the opposite of negative 30? I already know it's a positive 30. So look how simple that is. It instantly just creates our addition expression. However, let's go ahead and look at KFC again. So KFC says keep the first number, 52, change the subtraction to addition, flip the subtraction to addition, and then change the last number to its opposite. Last number is negative 30, so I'm changing it to positive 30. So you can see a few different ways to do the same thing. I want you to pick what you're most comfortable and make that a habit for yourself. All right, nice job today.